comes under 3S principle, which is pretty much important in terms of manufacturing industry. So to explain, just simplification is the point where there should be a disagreement between production and marketing department used to happen. Why in the sense production people used to say, as I explained, they try to reduce number of varieties so that they can utilize the equipments, facilities, the resources available in the industry effectively and make uh, profit, and also cost wise for the particular product will be lower so that customer will be uh, customer numbers will be increased, the purchase will be more, or the product will be sold more. But in terms of marketing department, since they are the voice of the customer, they will be favoring for high variety of components, stating that customer is demanding this kind of features, they need this kind of profile in that, or their expectation is like this, like so many things they will put it on the table. But it is not feasible, but they will be discussing, like a production team and marketing team, they will discuss together and make it simple, which is good for the industry and also will satisfy the customer. Okay, this is what all about simplification. The next topic we discussed about, so some advantages we discussed about simplification and what are the disadvantages also there. Then next topic we discussed about standardization, where we have to standardize what are all the materials we are using, what are the product we are going to use, what are all the machineries we are going to use, what method we are going to do, what kind of policy or principles we are going to do. We have to standardize to avoid uh, issues in making. Okay, so that is what standardization, where we discussed about the interchangeability concept. So what is meant by interchangeability is a concept like if one particular product is being manufactured by multiple operators, by the various machines in various locations, in the sense, all the components should have a desired quality, right? If it is not in the expected quality, we can't utilize it. Everything cannot be assembled or everything cannot be manufactured at one single place by single person by the single machine, right? So once the number of components getting increased, demand increases, then what we have to do, we have to distribute the components to be manufactured through the multiple people, multiple places, multiple machines. In the sense, everything should be in desired quality. For example, somebody making like a person or worker numbers Y is making one component in one industry, which is going to be assembled with another worker who made the component Z in location, different location, both should be assembled. That is, if it is not possible to assemble, there is a error in assembly, or if it's are not good, then there is a problem, right? So for that, standardization is important. We have to make that. So we attaining is not easy. So we have to plan properly so that they can able to attain. That is what the concept of interchangeability is. As I said, lots of material are made whole available here, and another shafts are available. Any shaft from here can be located with this or assembled with these holes, this wall, or anyone. Similarly, any other components you can name it. This is what interchangeability of the component. Okay. So what is objective is for standardization we discussed. If we make standard components, we could be able to reduce lots of wastages. We could reduce inventory, and also we could be able to reduce the accounting, and we can reduce the cost of the product, individual product. So that everything will be cost saving will be more. So this is what all about standardization. Then, if standardization in the sense it broad category classification is there. For example, basic classification. like a scale and weights, voltages, limits and fits and surface textures required. So these are all the things. Like for example, if they are making some weight, for example, one component, it should be 200 grams, and it is going to be assembled in one critical component. That weight is very very important. Like simply you can't add some basic weights. Each and every gram will grams or milligrams matter for the final assembly, right? So weight should be maintained. If they are telling this particular component should be of this much kilogram or gram or milligram, it should be there. Then only overall weight will be maintained as per their original plan. If not, the company is not going to be worked out. And limits and fits, for example, loose fit, interference fits, lots of fits available, right? You might have studied in computer-aided design or drafting principles, right? Where if you want to assemble one component to another, particularly the mating components or that surface mating, whether or whole base mating, that the surface finish should be there properly. Otherwise, limits and fits should be properly maintained so that it is properly assembled and the power or energy will be transferred without any uh, faults. Right. Another thing, dimensional standardization. Simple example, like here I given like a nuts, bolts, screws. But another example we could able to say is that mostly everybody having mobile phone, the mobile phone having SIM, right? Like micro SIM is there nowadays. So you can take the micro SIM and put it in the slots available in your mobile phone, like a slot one, slot two. So many things are there, right? Every company having that one. But if the size of making the SIM should be standardized, then only it will be fit into the particular mobile phone. If not, what will happen? It will be it won't fit and the communication won't be happen. So dimensional standardization is very very important. Then similarly, each and every standardization, like a material standardization, what kind of equipment we are using and what kind of process we are using and how much quantity we are, because for quantity in the sense economic order quantity needs to be identified. Then safety measures needs to be standardized. Simply you can't measure safety standardization without any proper guidelines. We have to strictly follow the rules and regulations given by the central board or government officials. As per their regulation, we have to maintain the safety measures inside our thing. We should be enforce that and we have to follow that. That is what the safety measure is. Then personal standardization. So what kind of worker we are going to select for particular operation. For example, for CNC machine operation, we have to take a person who is trained in that. Simply without much knowledge, if some we are taking that guys, then they can't able to manage. And also high level people, if we think also particular people needs to be there for the right place, right person. Okay, then only we can able to attain what all the requirement we are having from them. Okay, then administrative standardization, everything should be maintained properly. That documentation is very very important. Without documentation, if you are doing something, it won't be tracked properly. For example, if we make one automobile car and that while making car itself, they will have a record of who done this car, particularly in the sense that each and every component which is there in the car assembly will be noted down, and where and when, which machine, which operator and which shift it is done, it was done, like that they will be keeping all the records. For example, once it's go back to the customer, if reaches the customer, if customer files a complaint about some issues, which is like for example in my automobile seat, I feel like it is not comfortable for me, it has some error in that, or something is scratchy sound or noises are coming while I'm using like a power windows and that, then they will go back and track who assembled that. So what kind of component installed, whether it went for quality check, everything they will track. Okay, then only they could able to identify the source of error, then they can able to rectify. So documentation is very very important in terms of industry. In that one, we have to make the standardized procedure to make everything perfect. Okay, that is what administrative standardization. Then specialization, as we discussed, we have to make like products process individual according to that particular companies. We need to make a specialization. For example, product specialization in the sense, I instead of having like multiple variety, if I focus in everything, what we have to do is we have to focus on some limited product but with the multiple variety. So multipolarity in the sense, uh, if you take like a automobile vehicle itself, again I'm telling, our mobile phone, if you take one particular mobile, you will be having multiple features or enhancement. That kind of thing you can try. Instead of collecting every options available in the world, it is not possible for you to make it. Okay, just possible in the sense you have to invest lots of money, resources, and all. Okay, for that you have to make a product specialization for that particular company. So limited range of similar products only you have to focus. Then only it is feasible for us. So that kind of specialization and labor. The performance of the worker is very important to attain the required dimension or specification or features what we need. So we have to select the skilled labor for that. For example, tool room design in any industry is very critical job. Simply you can't take anybody for that particular job. So you have to select who is having good knowledge in terms of tool design. Then only he could be able to deliver the required product. Okay, for example, fixer design, jig design, tool design is very big art because it is going to give impact significant amount in the manufacturing, right? So that selection is very important. So this is like a selective specialization, maybe having like other specialization, process specialization we can do, or material selection. If we go, we can do the specialization. Again, like equipments. In terms of equipments, also we can do for specialization, like a particular wire EDM machine or wire ECM machines, or like 5-axis CNC machines, or special planner machine, something like that. We have to clearly plan, and we have to implement that kind of facilities in our industry to make the desired quality and output properly on time in efficient manner. Okay, this is all about specialization. So what are the 3 years we saw? Just to recollect you guys, simplification is the first step, and we have to do the standardization, and the final one is the specialization. With these three principles, if we work out, then only the industry or manufacturing industry will run in smooth manner. So every industry following that. So you guys need to uh, practice that in your thing. Okay. Then another one, we discussed about the interchangeability concept in terms of what like standardization principle we selected. For the interchangeability, again another opposite word or term or principle, if we say, it is called selective assembly. What is meant by selective assembly? Selective assembly. For a selective assembly, components are measured and sorted into groups by dimension prior to the assembly process. This is done for both mating parts. For example, again I am telling, the components are measured and sorted into groups by dimension. For example, this example, if you say like a hole and shaft, here there is a rod or shaft is there, and this component there is a hole. So what they make, for example, in terms of interchangeability concept, any of this shaft will be going inside this hole. For example, 1,000 number of shaft made, this 1,000 number of shaft will go inside this particular hole. That is what concept of interchangeability. But in terms of selective assembly, they make 1,000 component here of this one and also this component. Okay, the component A and B they make in terms of 1,000 example. Then the 1,000 component will be categorized or sorted out based on the measurement of dimensions. For example, what is the diameter of the particular piece with the particular tolerance value. Okay. Similarly, hole. What is the dimension of the particular hole? Like a 25 diameter, 25 millimeter, or what they will measure accurately in terms of tolerance value, and they will sorted out into two. Then they will select, for example, hole with 25 plus or minus 0.02 is the value they given in this. This is the hole value, and for the shaft, 25 plus or minus 0.14 and minus 0.10. The clearance should be 0.14. That is what the required dimension in the sense. If we randomly take like a 25 minus 0.2 this category and a 25 minus this one, clearance will be 0.08 millimeter only. But what we need the clearance 0.14. But what we attain if we select this specific size in terms of the hole and the shaft, we will be getting the clearance of 0.08 millimeter. So we won't be attaining the particular mating parts. Okay, but what we have to do, we have to select proper alternative. For example, here it is given like a hole and shaft pairing respectively, which gives 0.14 millimeter clearance. Our desired requirement is 0.14 millimeter, in the sense we have to select that like a hole with a 24.97 and 24.83. Similarly, 25.0 and 24.86. Another option is 25.02 and 24.88 millimeter, in the sense. By doing these two combination, what we will be getting the clearance value 0.14 millimeter. Similarly, in this combination also we will be getting the clearance of 0.14 millimeter. And another final one is like a 25.02 and 24.88. The difference or the clearance value is 0.14. If we select in this way, we could be able to achieve the mating. That is what required for us, right? So this is the concept of selective assembly. So two different principles. One is standardization, where interchangeability concept is there. Another one is selective assembly. In selective assembly, we will be measuring each and every component which is made in our industry, and we group it according to the dimension. Then take it from the slot A and slot B. We are trying to assemble by matching the principles of, like example I am telling, it's a clearance. With this clearance combination, we have to select it. So this is, so advantage also there for this particular product in the sense, thousand components in A and B. It is easy to assemble or create the final assembly. But in terms of interchangeability, attaining that thousand with this kind of varieties available, not at all possible. Okay, so where you have to invest lots of resources for attaining that, you have to be very careful about what kind of machinery or tooling selecting, or tooling you are selecting, feed rate you are selecting, cutting depth of cut you are giving, and what kind of coolant you are using. So everything is very much important. But comparing to that interchangeability concept, in terms of selective assembly, assembly, a bit flexibility we are having. So it depends on industries and what kind of product they are making. Then they will go for like interchangeability concept or selective assembly concept. Then we'll move on to SIM. And what are all the components available? What is SIM? Will discuss. I will discuss now. Okay. So SIM is CIM, Computer Integrated Manufacturing. Everybody knows about that, you guys. So where it came from? That in 1970s, SIM book explains this. The author Josh, he mentioned that SIM is the integration of total manufacturing enterprises, which is SIM is the integration of total manufacturing enterprises by using integrated systems and data communication. Okay, so SIM is the integration of total manufacturing enterprises by using integrated systems and data communication, coupled with new managerial philosophies that improve organization and personal efficiency. This is what given in that particular book in 1970s. Okay, so what are the concept here? It is mentioned total manufacturing enterprises we have to integrate. Okay, integrate the system using data communication, and also new managerial principles or philosophy we are having will be integrated together to improvise or improve the organization and get the better efficiency. This is what the SIM concept. Okay, so the SIM concept is came from where? It is comes under the digital manufacturing principle. So what is it mean by digital manufacturing? It can be defined as integrated approach to manufacturing that is centered around a computer system. So digital manufacturing is a concept of integrating the approaches which is being carried out in the particular industry through centralized mode using particular computer system. This is what digital manufacturing. Whether digital manufacturing, since that SIM definition came in 1970 itself in the book, whether in 1970 whether they have whether they implemented that digital manufacturing concept, no, this didn't happen during that time. It took lots of time, like until 1984, it didn't reach or implemented in the real industry. So what happened then? In 1984 only, all the people like machine tool manufacturers and the Computer Automated System Association and the Society of Manufacturing Engineers like SME. So three of these groups like machine tool manufacturers and Computer and Automated System Association and SME group collectively discussed and came up with a solution for implementing digital manufacturing in the real world. That is what happened. So, but when they implementing like a SIM, what are all the challenges they have faced is connecting the devices, because it is telling like digital manufacturing is integrating manufacturing system which is available in the industry, right? So that is what the integrating through the computer. That is what they mentioned. But what are all the challenges is connecting the multiple or different things which is there in the industry is the big challenges. How? But let me give the examples of these instruments. Like this is what your manufacturing machine, like a prototype of CNC machines, or name it like a big machine which could be able to machine. Then this is like a pick and place robot, or it do the welding operation also. Whether it will do operations or machining like a welding also it can do, or it will do the pick and place. Then here is the quality check like inspection systems like a CMM machine or Ferro. So all these machines is available in our this machine is available in our sim lab, and in this is our in our robotics lab, and this one is there in our CMM lab. Okay, in our Department of Mechanical Engineering, SRMIST Katanguruthu campus, we have all these machines. So what are all the purpose of this machine is this is for manufacturing. For example, this is for manufacturing, this is for material handling, this is for inspection. But if we want to integrate between these all these machines, what is the challenges is this machine is having different hardware. This machine having the different hardware and operating system. This machine also having different hardware and operating system. Connecting or interfacing between these machines have lots of challenges. So these people like manufacturing tool machine tool manufacturers and computer automated system association and the SME, they sat together and discussed, and they made lots of improvement policies and all in order to our standards and all in order to make this connectivity happen. Okay, there in 1984 only this process started. Okay, and SIM, it has three letters like C, I, M. What is for C? C for computer, M for manufacturing, I for integration. So, general principle, everybody knows that computer is a machine that can be instructed to carry out sequence of arithmetic and logical operations automatically via computer program. So, it is instructed. It is a particular machine which can be instructed to carry out certain tasks sequential manner using arithmetic or logical operation automatically. What way we can give the programming, computer programming. So through the program, we can define how we have to do the operation. For example, if you consider NC machine or CNC machine, in CNC machine using G codes and N codes like arithmetical and logical operators, we can write the coding and we can sequentially instruct the particular CNC machine to do the particular manufacturing operation. So this is for that purpose. The programming will be written through the computer. It will be fed to the particular CNC machine. So for this is what SIM. So this is comes under C of the SIM. Next one is manufacturing is M. It is the process of converting. We know the definition. It is the process of converting raw materials into useful products, like a tangible products. Again, we discussed about the difference between manufacturing and production. Like tangible, intangible will becomes under production. Only tangible is comes under manufacturing. Manufacturing also in nowadays people are used to say that both the things like only tangible or tangible and like intangible also considered as a manufacturing. Two different definition is there. Okay, but simply it is mentioned in this adding value to adding value. Okay, for example, from one machine there is a one machine another machine, there will be some process will be happening between that. So we do add value to the particular component or particular process. So by adding value through the process will give some meaning for the particular component, right? That is what all about manufacturing. So manufacturing is adding value through the process, and it is process of converting raw material into useful product. Okay, Then final term is comes here is integration. This connect the computer and manufacturing. We have computer which could be able to do programming sequentially as per our requirement. We can write the coding. Manufacturing, the machineries can perform the machines. What all the commands will be given. Okay, our instruction will be given. So how to integrate? That is the challenge here. So integration is came in digital manufacturing. So integration is connecting the computer and the manufacturing. So this is the process of integrating. Okay. So what is the definition? So these definitions came from I took it from MP Google book. So it is the manufacturing approach of using computers to control entire production process. That is the manufacturing approach of using computers, because computer here not only for programming alone, it also do the integration here. So to control means integration will be the entire production process. This integration allows individual process to exchange information with each other and initiate action. Okay, it will allow the machineries or processes to exchange information between each other. For example, one multiple machines are there, or individual machine. If you take like CNC machine, once it is doing the grinding operation or turning operation, it attains the desired dimension. What will happen? That machining, that depth of cut or feed will be stopped. The tool will go back to his position. The spindle will be stopped. The rotating spindle in the CNC machine stop. Then door will be automatically opened. The pick and place robot, yeah, pick and play robot will go inside the particular CNC machining center and take the component from the spindle and put it in the tray. Then conveyor will move the component from one machine to another machine. Another machine will the robot in the next machine will be taking that particular component fed inside to the spindle of the CNC machine for further operation, like doing some drilling in that one. So how it is connected? Once the CNC machine completes its machining process, it gives some feedback to the system, centralized system. Centralized system will like understand that okay, there is a process the process is completed. Next to sequence of process will be opening the door of the particular CNC machine. Then it will be done. Once the door open, again the signal will be going back, the feedback will be going back. Okay, door opened now, you can go. Like that, the information or instruction will be given to the particular robot. And robot go and pick and take that. So robot go is one option. For example, one location from this robot's position, it will reach that particular center of the machining center to take that to reach is one particular step. Once it take like a holding the adapt like a end effector holds the particular components is one operation. After that, pick and come back. The multiple sequence of operations is that each and every time it will be getting the feedback and giving the instruction to do next, to do next, to do next. So this is what all about integrating or exchanging information between each other to initiate the action. Okay, so hope you guys understand that what is meant by SIM definition. It is the manufacturing approach of using computers to control entire production process. This integration allows individual process to exchange information with each other and initiate actions. Okay, it makes the use of computer controlled machineries. CNC machines, if we say computer controlled machineries and the automated system, the example I said, like a conveyor or robot in manufacturing products. Okay. SIM combines various technologies like CAD, computer aided design, and CAM, computer aided manufacturing, to provide an error free manufacturing process that reduces manpower and automates repetitive tasks. Okay, so this is what. So as I mentioned, computer controlled machineries and automated system. It uses, this is what SIM, and it combines multiple technologies like a CAD, CAM, and it will provide, by combining this one, it will give error-free manufacturing processes and also reduces manpower and automates the repetitive tasks. Reduces the manpower and automates the repetitive tasks. So what does it mean here? If your repetitive task is there, like for example, if you take one assembly and one component and assemble it here and send, take it, assemble it, send, or another example like a PCB design, printed circuit board design or mobile phone assembly, or in mobile phone if you take that camera having multiple lenses and layers will be there, at least 5 to 6 layers will be there in that one. So if it should be assembled by manual, it is repetitive task. Every day they make like in numbers bulk, like 5,000 or 6,000 mobile phones every day, okay, in for a particular plant of mobile manufacturers. So if they assemble each and everything using manpower, it is a repetitive task, monotonous task. One thing, they'll be fatigue, like ergonomics point of view, they'll be feeling discomfort, fatigue, psychological, they will be affected. Another way, body wise, it's giving discomfort. That in terms of manufacturing or efficiency or accuracy or productivity if concerned, what will happen? The error possibilities will be there for during the assembly. So rejection rate will be more, or quality will not be attained as desired. Okay. So in order to avoid that kind of error, we have to reduce manpower, particularly in terms of repetitive tasks. During for the repetitive task, if we make some automatic principles like robots can do that assembly layer by layer assembly in automated manner, like sequentially, if we program it, it will avoid that manpower and also avoid the error. So this is the definition for sim. Then in a sim system, functional areas, what all the functional areas comes under sim is designing, analyzing, planning, purchasing, cost accounting, inventory control, and the distribution are likely to through the computer through the factory floor functions, such as what all the factory floor functions are: material handling and management, providing direct control and monitoring of all the components. So these are all the functional areas. So what are all the functional areas? Like as I mentioned, like a designing, analysis. So this all will comes under SIM. So every details inside, what are all the things related to the manufacturing or product will comes under the computer integrated manufacturing. So all these functional area are linked. So it is connected through computer with the factory floor function. What are the factory floor function? Material handling system or management system or control and monitoring of all the operation is one set. So another set is designing, analyzing, planning, purchasing, cost accounting, inventory control, and distribution. So this is one functional area. This group will be communicated to the material handling system or other mentioned here through the computer. That is what all about SIM. So what are the data flow happening? As I said, communication is happening. Computer through it is that this functional area connected to the other parts here. How it is happening through the data flow? There will be lots of data will be processed, right? So what are the data flow which is there? It is adapted from the particular reference. Okay, data flow in computer integrated manufacturing. So here is the design persons like R&D team who like a CAD designer or a CAE analyzing persons. Everybody will be there because design, analyzing, prototype, everything will be done here. So design process or resource persons will be there. Their information will be sent to manufacturing resources where will that real production is happening. Then that from once the manufacturing or production is completed, it will go to products. Here it's considered as a logistic. It will communicate to the customers. Okay, so logistic point of view of finished products will be sent to the customer. Then it will reach the customer and it will get the feedback from the customers, like a real user. So all this will be connected to the centralized system, which is a cyber system. So that is what we are discussed in our introduction itself, connecting customer through like a customer also one of the thing in terms of Internet of Things, like industry 4.0. This is also one of IoT is one of the thing where cyber security is important, means their information means like a cloud will be there where all the information will be stored, right? So this is also kind of cloud data. So in the cloud data, all the information will be processed. That the design details will be stored in this one. From that only, well, it is not now nowadays. The designers will be taking the printout of the draft sheet and will be given to the manufacturing industry. That error long back, it is now gone back. So gone. Now the people will do the design and they will send the design drawings to them. Then design drawing will be converted into manufacturing drawing in the system itself or computer itself, or somebody will do that and process in it. Then that data will be communicated to the manufacturing person. Then they will do like selecting what kind of process planning and they will do. But here in terms of design resources, if they make some new component or when they make some process planning also, what they do is first they check the what kind of requirement from the customer, voice of the customer through the marketing and finance team, and get the information. Okay, once they get the information, they will check whether are we done this kind of component, are we made this kind of component in our industry. They will check in their database. Once they check the database, they will retrieve that information and they will do some alternation or updation. Then it will be sent to. If nothing is done, then they create something new. If there is already been done in the particular industry, they update that and send for the next operation. In manufacturing operation, like everything like capacity planning, material resource planning, or manufacture resource planning, or ERP, enterprise resource planning will be all happened all through this centralized system, like a cyber system. Then dispatching and delivering to the customer, like logistic principles will be discussed in this area also through the centralized system, because where and when and how it is dispatched also should be tracked that then customer. So customer once it reaches, and also it won't end. Again, there will be a follow-up. For example, they are selling something, they will note down each and every ID with the proper ID, they will give that details. Once the customer is giving some feedback, like for after service or complaint against the component, everything should be go back to the central system. Then all will be communicated through again in this order. Okay, it will go to the logistic team. The logistic team will be telling, okay, this product sold to this person or through this customer, through the consumer, or through the clients. We sent like this. Then it will come, okay, in which plant and when it is got it from the particular manufacturing plant, it will go back. Then manufacturing plant will be checking which machineries it is done, who done, which shift it is done. Okay, then is the, again error in the sense it will go back who done the design. Like this is chain of operations, right? Once we have all the data in centralized manner, it is easy to avoid any errors and also improve the quality which is needed and also reduce the cost of the particular product. This is the data flow in SIM. Here again, the data security, cyber security is very, very important. That is what in industry 4.0 people are discussing. Okay, so we'll discuss about that in related units. Okay, then this is the SIM wheel. So the sim wheel category, it's like a layer by layer, we could able to see. Okay, the first layer and this is the second layer. Then inside is the third layer. Then it goes inside the core of integrated system architecture. So here, if we consider like a manufacturing management is one, another one is marketing is another one, and strategy planning, finance. So these four are the major wheel for major layer in the sim. Then once it's go inside, if you take like a product process or factory information or manufacturing planning and control will be there. So in strategy planning, if we go, manufacturing planning and control will comes under the strategy planning, like PPC, product process product and process control, and shop floor control. What are the material selection? What is the scheduling? And what is the quality planning or facility monitoring? Everything comes under manufacturing planning and control. Okay, then factory information. If we say take it as a factory information, how the components are assembled, how it is being handled between machine to machineries, what kind of inspection is being carried out for the particular component, and what kind of material processing is happening. Everything will be stored in the factory information. Then product processes like inspection or documentation, where it is done, who done this, which machinery, in which shift it is done, and what are all the analysis like validation principle they do or verification principle they do. Everything will be stored in this layer. So all this information will be communicated as a common data to the particular centralized system, like integrated system architecture. It will give all the data wherever and whenever needed to the required person. For example, like materials or quality control or inspection technique will be stored here. It may be useful for the documentation people stating that who done this kind of inspection, what kind of inspection method is used in that, or assembly. Assembly in the sense what kind of components, like whether they used interchangeability concept or selective assembly component, what is the clearance value available for between component A and component B during the matching. Everything will be given from the assembly through this the integrated system, and they will document it properly. Okay, so hub will be centered, all the information will be sent to the individual team. Okay, for marketing people, that quality is also will be useful. Documenting the information also very important. That's why it is coming under the marketing. And manufacturing management, if you consider, they need to verify all the information. They need to know the factory shop floor details also. Finance is very crucial. They have to control all the process, and they have to give enough resources for that. So they have to monitor whether the expenditure is used in the right manner and in right direction. So everything is connected in this one. That is what the symbol. So I recommend you guys just read in detail in the textbooks, so that while writing it will be easier for you guys. Okay. So it's a basic understanding. You please read that book. Okay. Then what are the process which is involved in SIM? So as mentioned, it is combination of many processes like a CAD and CAM as mentioned, computer design and computer manufacturing also involved. So CAD is one process involved, and prototyping. Once the R&D people they make, instead of making or machining that in real world nowadays, they make a prototyping using additive manufacturing or 3D printing or rapid prototyping. They make a prototype of the particular component and do some testing, like fracture testing or impact test, basic mechanical testing. If it is needed for the particular product or component, they do that. So the testing will be there. Then determining the efficient method for manufacturing by calculating cost involved, and what kind of production methods and how much volume we want to, and how we are going to store the particular component, and we are going to distribute. Everything will be process planned. That is also one of the process inside the sim. Then if we decided whether are we having enough material for making, for that we have to consider ordering of the necessary materials. Not only materials and also tooling what we need, we have to plan. And also are we having enough workers for doing this operation also needs to be considered. So then we have to order that accordingly. Like materials means we have to order material. If we need manufacturing machineries means we have to order that. If we need more workers according to the demand of the company, we have to recruit many people according to the specialization or need, whether standard employee needed, we have to choose. Then computer manufacturing of the products with the help of CNC. Indirectly, it will go for the production. So these are all the process for SIM. It also continued, like once we do, once we complete that machining using CNC machine or NC machine or conventional machines, what will be done? Quality control. We have to check quality at each space. For example, one machine is manufacturing or making whole. In the sense, immediately if we check that the dimensions which achieved as per the desired standard in the sense, then we can sell the component to another. If we are not doing that, at the end, if one component take one component in that multiple holes with variable dimensions, sizes, diameter, I mean like a 10 millimeter with plus or minus 0.1 accuracy, or 20 millimeter of diameter, or 5 millimeter diameter of hole, or 12 millimeter diameter hole, like many holes done on that particular thing. Like casing for the engine has lots of holes, right? That will be should be done properly. And also they make a threading on that. It should be checked then and there. If it is not checked then and there, at the end, if they go for assembly of whole engine cover, we can't achieve that desired quality. So quality control is at each phase of the development is very much needed. That is also one of the product in that. Then assembly, product assembly using robot or some other automated meaning, and quality check automatic storage. After the quality control is different, quality check at the end, performance test will be done. Then we have to use store that properly. So automatic storage and retrieval system is very very important. So automatic storage also there. Then automatic distribution of product from the storage area to the awaiting lorries or truck means we finish the component and stored in proper order. Then we have to dispatch the components from our industry to the customers through the suppliers. Okay, that should be there. Then updating the logs. Once we supplied everything, we have to keep all the data, how much we sent, and what kind of return of investment we have received. We are sending some details, means the documentation should be maintained. Everything will be properly maintained. These all the process comes under SIM. So that is what also there in the SIM wheel. Okay, SIM wheel is integrating everything through the integrated system architecture in the common area. So all this like a design which is comes under drawing or designing. Like a data flow I explained here, it is coming. Okay, in manufacturing or logistic and customer or finance, everything will be connected. So with this one and also SIM wheel, you could understand what are all the process available in SIM. Okay, starting from the design till the dispatch and then maintaining all the logs. Here, not only like ending, once we send all the components from our assembly from our industry, whether our work is done, no. We have to constantly keep the customer track the customer, whether they have any opinion or whether we have to do any improvement, whether they are giving any complaints. We have to track it down. Okay, this is also processes involved in SIM. Then what are all the advantages of SIM? It is basically error reduction. So due to error reduction means if we are reducing the error, what will be there naturally? The productivity will improve. What is meant by productivity? With minimum resources attaining maximum output, right? That is the ratio. It's kind of efficiency we can say. We will be investing minimum resources or investment but attaining lots of output or a huge output in the sense that is what your productivity. So in that if we invest minimum investment, if we do minimum investment, the error is there in that one, can we able to get the maximum output? Not possible. So error reduction possible if we do proper planning or controlling everything stage by stage, phase by phase. That's why the productivity will be improved and the error also will be reduced through the sim principle. And reducing man involvement. So mostly we automate the system through computer and machineries. So reducing the man involvement and number of process steps also will be reduced. Instead of if we do planning properly, instead of doing like multiple operation for a single feature, we can combine many operation into one. Simple example, selecting tool like drilling and reaming tool combination or punches, combined punches if we do all together, then we can able to reduce. In terms of cooker manufacturing and all, they do lots of punching operation, right? So like there will be lots of sheet metal, there will be a punching operation, like a punching coin will be there. Maybe you might have studied in manufacturing technology, right? Combining the operation in order to avoid or reduce number of steps needed. So reducing number of steps will lead the reduced time to market, right? It will enhance output, also will attain maximum output. It will improve the productivity also. And number of parts in assembly needs to be reduced. Instead of making small components for doing something, we have to plan or design accordingly to reduce the number of parts in assembly. So this recently can be achieved using additive manufacturing. Instead of creating if they want to create complicated component, what they used to do, they segregate or divide the component in multiple features. Individually they make, then assemble it. It creates some error in terms of assembly. Nowadays, using additive manufacturing, they can do the 3D printing. They can do rapid manufacturing. With that, they can able to number of parts which is needed for the assembly. So all this feasible in terms of SIM. Okay. Then agile manufacturing. It's a speed to delivery is agile manufacturing. How quickly I'm going to respond to the market. Suddenly, market is demanding new. The competitor for us is ready to launch something new. Hence, the customer also expecting something new from our side. Means they are our reliable customer. They are expecting means we have to fulfill their requirement, and then we have to react quickly to the need of the customer in quick manner. That is what agile manufacturing all about. How quickly we are responding to the market demand is the speed. That is what agile manufacturing. This is also one of the advantages of SIM. Again, everything is having all the components or things inside the industry are connected. With that, if we maintain properly, speed or agile manufacturing is feasible. Then flexibility, quickly react to the market condition. Like for example, if the company is making only circular component or prismatic components, then we have to have a flexibility in enhance the whether market condition is only focused on prismatic component or only required in circular component. Accordingly, we can rearrange our working cycle and we have to deliver the need. Okay, where flexibility also should be there. If a customer is like recording prismatic component related thing, if we are telling no, we can't be able to make, we have only circular in the sense, no meaning. So we have the flexibility. And similarly, we have to have a speed to produce that with error reduction, and everything will be integrated through the documentation in the computer, and using sensors we have to monitor. Using sensors we have to monitor in the sense CNC machine is running, the speed of the spindle speed, cutting speed, everything will be measured through the sensors, and we have to get the feedback whether the machining is done properly or efficient manner. We have to track it back, right? This is what the advantages of the SIM. So how the SIM is integrating? So it is drawn versus SIM integration versus time in this graph. First of all, physical integration, application integration, business integration. Physical integration and application integration means what all the possible application can be done with this particular component. Our physical integration, this is how we can integrate the machineries like a machine A, B, C, how we can able to integrate. That business integration means like inside we do financial planning and marketing team, and other competitor, other suppliers will be there. All the thing will be needs to be connected. This is all comes under system integration. Then what are the usage of SIM? If we say industrial and production engineering people will be using that SIM, like we people and the mechanical engineering people and the electronics people also, they will be using the same concept for PCB design and IC designs like integrated circuit design and printed circuit board design, PCB design. This is basic usage. And what are the challenges available? So this is adapted this figure is adapted from this reference. So challenges will be while implementing SIM is how we are going to integrate components from different suppliers. That is what we from the beginning we are telling. Integration is not at all easy, so we have to feel that integrity. But whether that company people are coming under with like a common OS like operating system. Nowadays we can say like a Windows or Linux, like that we can say very few well understood or well established OS. But when you go for industry or machineries, like various controllers are there, they are not ready to come forward and integrate together because each having their own integrity or security. So they are not so integrating. So what we can do, like when connecting the machine, RS-232 cables are there, like correct category of cables are there. Using that, we can able to connect. So integrating components with the different suppliers is the biggest challenge in terms of implementing SIM concept. Then data integrity, how we are going to keep the data integrity or safety of that data is another big challenge. It is also one of the challenge in our industry 4.0 concept or digital manufacturing concept. Then process control, how we are going to control that, what sequence the company is moving from one place to another place, whether it is ready. Here, like a designing center is there, information communicated to the controller room, then prototyping they are making, then it goes to the what to say production line, where lots of machines available with the conveyor belt and production line doing the process. Automatic AGVs, automated guided vehicle, these are all the AGVs will be picking play taking the output from the particular machine or moving the components from one place to another place. And storage and retrieval system is there. Then it will be that it is storing is done, then it is giving like a delivery to the storage is here and it is delivering to the customer through trucks and things. So this is from input. AGVs are used. This is initial storage. Then it is going to the manufacturing plant and the production is done. It is again stored and the distribution is happening. So this is like a one process control using that. So these are all the challenges. Integrating of components from different suppliers is one challenge, and data integrity is another challenge, and process control is one more challenge. So these are the challenges. What are the subsystem, which is comes under SIM umbrella? So CAD, so many things. These are all the main thing. CAD, computer aided design. CAM, computer aided manufacturing. FMS, flexible manufacturing system, also comes under subsystem for SIM, which is comes under SIM umbrella. Then computer aided engineering, where you can do analyze. Uh, then quality control, CAQA, no, computer-aided quality control and assessment. That is what I added as A, and production planning and control (PPC) and ERP, enterprise resource planning. All these things will be considered in ERP, mainly focused on finance and that, right? But this also will comes under sim system subsystem. Okay, so just understand. And what are the devices which is used, as we saw in previous slides also. You will be having like CNC machines or material handling machines or DNC machine, PLC all comes under the sensors, robots for material handling, and computers to process the data or interfacing that. Softwares will be used for like control the CNC machines, or like a modeling purpose, or financing if they are doing, they will be using, or ERP planning they do, they have a software. And controllers, networking and interfacing, very very important, like data communication through the network, interfacing also. So these are all the device and equipments. So DNC is a direct numerical control. It's like a next level for the CNC. So NC is the basic level. Next one is the CNC level. Next one is the DNC level. Like a multiple CNC machine controlled through the centralized server machine called the DNC. So we'll discuss about NC, CNC, and DNC in later part of the lecture. Okay. So these are all the devices and equipments required for SIM. Then what are all the technology? FMS is one of the technology. Factory manufacturing system is one of the technology. Then automatic storage and retrieval system is one of the technology. AGV, automated guided vehicle, is another technology. Robotics, like a pick and place robot, conveyors, which comes under the technology. And storage system or conveyor system is comes under one of the technology. And what are all the software they are using is comes under the technology. So these are all the technologies available for SIM. Okay. Okay. So with this, I'll be ending this particular lecture. In this lecture, we discussed about 3S, refreshed about 3S principle, simplification, standardization, and specialization, and then we started with the SIM introduction or definition, where it came from, and what are the components available, and what are the processes involved, what is SIM wheel, and what are the devices required for SIM to make, what are the challenges faced in SIM, and what are the technologies used under SIM we discussed. Okay. In next topic onwards, we'll move on to NC and CNC, DNC. Okay, I'm winding up this video. Thank you very much. All the best. Welcome back. This is Murli Subramaniam. So this is lecture 3 for the unit number 1, Introduction to SIM. So in lecture 2, we discussed about standardization. For example, why standardization we discussed is all about